Welcome. We are. I got a light. Thank you. So, last section. This can be very, very easy, but it can be very, very tedious. Does that make sense? No? You know what's tedious, people? It just takes a while. Okay? So, what we're doing today is we are going to use, let's see here, we need to understand the inverse of a function may or it may not be a function. So it can or cannot be a function sometimes. We'll talk about some of the details about it. Really cool stuff here because it just kind of goes to prove that everything in mathematics can be undone. Addition has its inverse operation, which is multiplication has, squaring something has the square root. Functions also have an inverse. So let's get to it. You guys ready?
I mean, as ready as I'm going to be, I suppose.
What?
I said as ready as I'm going to be, I suppose.
As ready as we're going to be. So finding the inverse of a relation. I've got a relation up here. This is called relation S. And in its domain, it has 0, 2, 3, 4. In the corresponding range, it's got negative 1, 0, 2, 3. I want to find the inverse of this relation S. I'm going to denote it as x, y's. And it's going to look like this. Negative 1, 0, 0, 2, 2, 3, 3, 4. And there is the inverse of that relation. What happened, Kaylee? You all right?
Yeah,
Looks like you were thinking or something.
that was
What's easy?
what you did.
What did I do?
Wait, y is the x. X is the y.
Say that one more time because I probably couldn't say any better myself.
You made the y's the x's and the x's the y's.
I made the x's the y's and the y's the x's. That is absolutely correct. To find the inverse, I take the x's and they become the y's, and the y's become the x's.
Don't jinx it.
Okay? Wouldn't it be nice if I just said that's all I got for you?
That would be
That would be nice, but it's probably
my
unlikely.
favorite.
All right, find me the inverse of relation T. Find me the inverse of relation T, please.
This is a trick question. I'm very upset because I'm getting
But you and I don't make mistakes, so we're okay with pen. Is the last.
I thought you were going to start singing Last Christmas.
You want me to check that? Is that what you're trying to do? Oh. Oh, just the people that were in the cabinet, that were gone all day yesterday. You guys can turn this all in until Monday. Ooh, hold on. That's got some lavender. No? No, that got all the essential oils. So. Got some mint. Man, there's definitely mint and lavender in there. Maybe some tea tree oil. Thank you.
You don't do it.
You don't like it, you don't need it,
I
right?
got my wife's Christmas gift. That's what I
That's amazing.
Is it? What is it?
It's like a lotion.
Oh, it's a lotion.
Guess you got
I thought you were smelling like diffuser oil or something else.
That's good stuff.
don't really know what it is. What's
You
it?
just gave away some gold. Thank you. All right, so hopefully everyone wrote the same thing where these became y and these became x, yes?
Good.
If you did, then That sounded very sarcastic, like, no, that's not what I did at all. You probably just didn't write it all, did you?
No, I didn't.
Okay. All right. Questions on that then? We're good with the inverse relations?
Yeah.
Yep.
All right, now. That's when they gave us data. They gave us the numbers. Now we need to find the inverse of an equation. So, we get an equation, and we need to find its inverse. Can you guys see this equation here?
Yeah.
So, how do we do that? Let me go and write this down real quick for you. This is y equals x squared minus 1. And I need to find its inverse. In the last problems, we figured out the main purpose, or the main way of getting an inverse. And that was by taking x and y and swapping them, right? That's what we did. That was pretty much it. We're going to take that same idea here, and this is our original function. I'm going to call it f of x. So that's the original equation there. Y equals x squared minus 1. I'm going to take x and y, and I am also going to swap them. So that's going to become x equals y squared minus 1. Okay? That is, technically that is the inverse function. But is it in the way that we're supposed to have it? No, it needs to read y equals, doesn't it? So all we have to do at this point is solve it for y. So I'm going to add 1 to both sides. That's gone. I've got x plus 1 is equal to y squared. How do I get rid of that square? Square root both sides. So this is gone. So I've got y equals the square root of x plus 1. And there, my friends, let me show you the notation for this. This is not f of x. This is f inverse of x. Notice I've got f to the negative 1 kind of thing. That doesn't mean it's the function to the negative 1 power. It is the inverse. Let me hit plus here. Can you guys see a little bit better back there?
Yeah.
Okay.
Wait, can you say why you put minus 1 again?
It's just notation telling me that that is the inverse of the other function. Yeah, this is just notation. This is notation. So if you want to call this y to the negative 1, kind of the same idea, okay? Not so bad, was it?
You still
Good.
got more.
What?
You still got more.
Touche. Alright, are we done copying this page? Alright, you try this, man. Do it.
You can't do
If
this.
you're happy and you know it, clap your hand. If you're happy and you know it, clap your hand.
Not very happy.
If you're happy and you know it, and you really want to show it. If you're happy and you know it, clap your hand.
Hey, don't do it in my ear. That's what I do. I just shoot the extra outside. That's as far as I got. There's an extra number.
This is
Mr. Millennials, will we change this to y? Or just put 2x and go second y instead? What?
A little bit more to that.
Leave it in like a jungle?
Oh, I guess you could, huh?
That's my favorite thing. I went to work last year, like, that time, and that was my
They put it in the
That's my favorite.
Thank you. Sounds like you have it. So there's my inverse. I just got to fix it, right? So I'm not fixing it is not the hard part. Because you've been doing that since junior high, right? Solving two-step equations. Oh, this is supposed to be my F inverse. Ignore that. It looks like a broken flash symbol. So this becomes x minus 8 is 2y. I'm going to divide both sides by 2. So I've got y equals on the right side. I'm going to switch it over to the left side. This quotient is 1/2 x, and this quotient is negative 4. So y equals 1/2 x minus 4.
I actually got it right.
Yeah, we put negative. Alright, we were getting something.
Negative 4 plus 1/2 x? Yeah, it'd be the same thing. As x minus 8 over 2?
No, isn't 1/2 x the same as x?
Yes. Here's some other versions that you might have ended up with. That's all the same.
Will not Excel accept that?
Let's try one. Oh, that's my example. I can do it. JK, smiley face, LOL.
So when you're writing numbers, is what I ended up doing. I moved like
Put
the
it in that way.
the 2x to your over, so you only like worry about the x and y, not the numbers that are in front of it. So like how it's 2y, or
Yes.
it was, yeah. So you're only worried about the x and the y. You leave the 2 there, right? You don't leave
Yeah, all you're doing, to find the inverse, all you have to do is make x the y and y the x.
Okay.
Once you've done that, that is the inverse. Technically. What you need to do at that point is simply algebra to get back into an equation of some sort.
Because when I did, I moved 2x to that side and y, so 2x equals y plus 8 is what I ended up doing.
No, then that's still the same thing. That's still the original function. You do not have an inverse until you've swapped x and y. What's up?
So is the point to kind of isolate y on one side of the equation? Is that kind of what
Well, that's what we've always done, right? Because if we want to write it as a function, we know that y is kind of the
base point of equals?
is the function method of writing that. So we can switch y from f of x and still have the same function. And that's what we're trying to do. We always want to get y equals. Yeah? Y. Y. We're always finding y.
So you would just apply the inverse and then move the y to the outside after the inverse was applied?
Hold on. Say that one more time.
Would you apply the inverse to the equation and then move the y to the opposite side when it's applied? Sort of.
I'm not sure I understand what you're saying.
Like,
Here's the only thing that you need to know. This is my original function. We'll call it a function. It is an equation, right? But we'll say that's the original function. Go ahead.
You can put x over 2 and that'd be the same thing.
Yeah. Yeah, you can. Once I swap x and y like I did here, this, my friends, is the inverse function. It is the inverse function. It's not in the normal way that we present it to people, right? Don't we always say, oh, this equation is y equals blah, blah, blah? But technically, that is the inverse function. You just need to make it so that it reads y equals, and mainly for the purpose of plugging into a graphing calculator so that you can see what's going on. Does that make sense?
yeah.
So, here, I want to show you something. Since we're already here, because we're going to get to it anyway. I'm going to go over to Desmos. Bop, 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 bop. What was the original equation there? Y equals 2x plus 8. Okay, so there's my equation. Now, when I swap those, x equals 2y plus 8, there's the other equation. They are already inverses. Finding an inverse is so easy. Just swap x and y. Swap, you're done. Boom. Well, and with Desmos, it's even easier now because we can just graph them together, can't we? Okay? But take a look. Does anybody see? Well, you can't really see much here, but if I zoom out, do you guys see anything going on here? Anything special? They intersect, right? Let me add one more. Let me add one more function in there. And then let's see if you can find.
Flip it.
I'm going to add x to the mix. You guys see x right in the middle? Do you guys see any relation between that and the line now? What is it? That's exactly right. Say it one more time nice and loud so even the recording can hear you.
The reflecting over the x?
Yeah, inverses reflect over each other on the x line. So if I could take this red one and reflect it across this, I would get the inverse. And what's really cool about that is if I were to take a function and add to it its inverse, I would get the x function back, y equals x. So if I take, let's say, I don't know, this point here, and add it with its corresponding point here, guess what I'm going to get? X. Good. Because they're symmetric across it, y equals x.
Is it safe to just call it axis?
What's it have to do? Let's talk about that. The point I'm making is what Bateman just said. A function and its inverse are symmetric about the line y equals x. So if we go over to the next problem I was going to have you do, which is to graph these relations and their inverses, let's take a look. So here's that one. Guys, write that down real quick, please. Write her down, write her down. All right, you guys got those copied? Let's take a look at those functions in Desmos. What was the first one?
Y equals x squared.
So it is x squared. What? Minus 1? Let me clear this ink over here real quick. Clear ink. So, you guys see my little parabola there? Yeah? Now the other one, I'm actually have to punch it in two different pieces because it's a plus and minus, right? So I'm going to do the positive version right now, which is, what is it, x plus 1? X plus 1. And then the other half should be negative square root of x plus 1. So, can you guys see that if I zoom in? Do you see the symmetry there? So a function and its inverse will always be symmetric about the line y equals x. That is really, really cool.
So it ended up making
The parabola turned on its side. Reflected across the line, y equals x.
Is it just splitting straight between the center of the parabola?
No, it's not splitting right in the center. Because you see this kind of comes at an angle.
No, I mean, like, that's what I'm saying. How it just like axis of symmetry.
Like axis of, no, it's not nothing to do with the axis of symmetry.
See, like, this, like, it makes like a weird little,
The range of looking thing?
yeah, 'cause that's like exactly.
If you take a look at this part of the parabola in the orange, the inverse of that piece is this piece. Oop, that was horrible. But do you see that symmetry there? And same thing with the other one, right? Now, this kind of takes us to the point that we're trying to make on the objective today. The inverse of a function may or may not be a function. Did I say that right? The inverse of a function may or may not be a function. That sounds weird, doesn't it? Here's what they're saying. This is a function, yes? Its inverse. Is its inverse a function? Why not? Yeah, because if I did the vertical line test, I'd cross here and here. So is the inverse of this function a function? No. And that's the point we're trying to make. So understand that. Sometimes the inverse of a function is not necessarily a function itself. What you will learn, though, that as we go on is that we just ignore parts of it sometimes. So let me clear this. So this is the one that makes it not a function. We'll ignore that. And typically you'll see that the square root of this is the inverse of the other function. Or if we need the other half, then we would use the other half instead. Does that make sense?
Wait. You have to do that?
No, don't worry about that. I just said too much. I get excited and I jabber and I blah, blah, blah.
So you can just stick to it.
What's up?
Is it because it's plus, it's not both, it's either plus or it's minus?
Right. But we're going to do plus and minus. Okay? All right. We already did that, didn't we? Find me the inverse of this function, please. Go.
Inverse of that function.
Yes, sir.
I swear that.
Dylan, you all right? So there's our inverse. Let's fix it. Thank you. Thank you. There's our inverse. Let's fix this. I have to square both sides. X squared is equal to y minus 2. Take that 2 over, so you've got x squared plus 2 is y, meaning that y is x squared plus 2. And if you want to see that symmetry, yeah?
That's the range.
No, that is the inverse. I said find me the inverse, okay? Now,
Find the range. No, it's not that.
domain and range of this function. Let's go ahead and graph this. What was it? Square root of x minus 2. Square root of x minus 2. Just take a minute to make sure that you confirm that it looks like it's like you think it was supposed to look. It's a minus 2, so you should have gone 2 units to the right. So, domain range, you ready? Here's how I do it. Go to the x. That's my smallest x. And it goes that way, doesn't it? So domain, x is greater than or equal to 2. Range. What is my smallest y? 0. And it goes up forever. So range, y is greater than or equal to 0. Math.
So you can keep that there for a second. And then you just see the
See those fingers, not those fingers. See that fist of 5?
She's like, I got it.
I have a question.
5 means I can cheat somebody. 4 means I got it. 1 means I don't know what you're talking
I'm
about.
gonna do like a 3.5.
I have a question. Six question.
Was your very last equation that you came to x squared plus 3 equals y? Is that it?
What?
Okay, I just want to make sure I had the equation.
Got it? Good?
Well,
No?
go back to Desmos, but that's fine.
Are you gonna graph the?
Where's Steph? Alright, that's everything I've got, guys.